In the recent times, virtual and augmented reality systems have revolutionized the human-computer interactions in a 3D world. But the main limitation of such systems are lack of realistic haptic feedback during interactions. An accurate, stable and smooth motion patterns is necessary for smooth and realistic feedback generation. Unfortunately, the real-time motion data are unstable and cluttered due to occlusion of the tracked elements and depth sensor range limitations. This video shows the motion pattern detected and the actual human motion during a virtual tapping task. Due to occlusion of the index finger, the detected motion is very unstable. How to generate smooth real-time motion patterns for haptic feedback rendering. We propose a hidden Markov model-based motion synthesis to create smooth motion patterns for haptic feedback generation. The methodology is a 6-step process. The first step being the capture of the motion data from skeletal tracking motion sensors during the intended gesture. Next, we retrieve the occlusion-affected unstable motion data from the sensors for processing. Multiple models trained for detecting the motion states from the data are run parallel in the third step. The primitive motion elements are stored in the lookup table. These primitive motion elements are loaded according to the states of the model.
Further smooth motion elements are synthesized according to the states of the selected hidden Markov model.
The smooth motion elements are then used for the haptic feedback generation in step 5. In the final step, a real-time vibrotactile feedback corresponding to the human gesture is rendered using a haptic wristband. In the final implementation, the model is tested for virtual zooming task. A virtual circle during zooming was selected as the motion element. Smooth vibrotactile feedback was generated using the proposed method. Next, a virtual tapping task with occlusion was selected. Here too we were able to generate smooth feedback with accurate timing.